Well, welcome everybody. My name is George Rogowski. I'm a professor here and a long-standing fan of quasars. And we're here to celebrate the life and achievements of one of our most prominent Caltech professors ever, Maarten Schmidt. I'd like to invite Fiona Harrison, the chair of the Division of Physics, Math, and Astronomy, to also welcome you.
So my remarks will be very brief. I just want to say how glad I am that we got to do this and have members of the family join us and former colleagues and Caltech faculty. Astronomy has been a flagship enterprise for Caltech since its founding. And Maarten was certainly one of the greats of Caltech astronomy. And few people, though, will remember he was actually division chair for 3 years. I know that because this picture is in my office. I look at it every once in a while. And led the Hale observatories, which was what the Caltech optical observatories were called in the day. But of course, his greatest contributions to Institute service were through his science and the lasting impact that he made on all of us as a result. And so we have many people here who will speak to that. George Dragosky, I'd like to thank in particular for agreeing to organize this. He reminded me no good deed goes unpunished. He organized the 50 years of quasars, and so I said, George, you're just the person to do this. So he's going to tell you, walk through some of the history of Maarten's life and career, and then we will hear from many eminent people about how he changed their perspective on science. Thank you, George.
Well, thank you, Fiona. So let me go through a few highlights of Maarten's career. It's a great picture, huh? Yeah, professors don't look this handsome anymore. So he was born in Groningen in December of 1929 and attended the University of Groningen, but then went to graduate school in Leiden, where he was advised by Jan Oort. It's a pretty good pedigree to have in our business. He arrived to Caltech in 1959, first as a postdoc, became professor, eventually became Francis L. Mosley Professor of Astronomy, and then emeritus. As Fiona mentioned, he served as the division chair for a period of time, as well as the director of Hale observatories, which also included Carnegie observatories at the time. So here is a great picture of the Caltech astrophysics faculty when Maarten joined. And you can tell that was a pretty distinguished group of people. So this shall never be repeated again, I think. Originally, Maarten worked on galaxies and stellar populations. There is Jan Oort's influence. He came up with Schmidt's law of star formation. We may hear more about this from Rob Kennicott later. But the big thing came in 1963 with the discovery of quasars, which changed astronomy profoundly for a while, changed his life, many other lives too. And led him to fame, if not fortune. So here is the cover of the Time magazine. He was only the third astronomer to receive such an honor. The first two were Carlo Shapley and Edwin Hubble. And since then, some lesser lights like Carl Sagan. So that culminated perhaps with Kavli Prize in 2008, an equivalent of Nobel, which he shared with Donald Lynden-Bell, who came up with a physical explanation for quasars. But he also got a lot of other honors in between. He won the Helen Warner Prize, the Henry Norris Russell Professorship, the Rumford Prize, the James Craig Watson Medal, Bruce Medal, Gold Medal of the Royal Astronomical Society. You get the idea. He was also a member of both American academies, the American Academy of Arts and Sciences and National Academy of Sciences. Also corresponded to the Royal Netherlands Academy, member of German Academy of Sciences, Leopoldina, member of the American Philosophical Society, Norwegian Academy, and also served as the president of AAS. And another honor is an asteroid, 10,430, was named in his honor. And in that game, the lower the number, the more honor it is. So I would now like to invite Martin's daughters to say a few words from the family side.
Thank you, George and Fiona, for your kind words. It's so good to be here. On behalf of the family, we would like to thank George and the organizing committee for putting together the celebration of our dad's life. I'm Anne, Martin's youngest daughter. I'm here with Marika, my sister. Unfortunately, our eldest sister, Elizabeth, was unable to attend. For those who may not know, our mom passed away about 3 years ago, and Dad just over a year. We had an inkling that there might be some media attention, but I must say, we didn't really expect that much, but we weren't prepared for the outpouring of condolences and memories. So there are so many stories that we could tell, and some prominent ones that come to mind. Like when he received the Golden Plate Award and met actors like Clint Eastwood, who wasn't very interesting. And,
according to Dad.
Well, of course. And Olivia de Havilland, who took a very strong liking to Dad. And Charles Schulz, who drew Snoopy for my mom. And at the time they met, and the time they met George W. Bush, after receiving the Kavli Award, the president took maybe too much of a liking to my mom.
And if he only knew.
My dad treasured coffee with his dear friend and colleague, Wall Sargent, both members of the Deadwood Society. I loved hearing stories of who was kicked out of the society for doing something significant, like not being Deadwood after all. So many of you knew my father as a scientist and professor, but to us, the three daughters, we knew him first as a loving father and affectionately known as Pa. Our parents immigrated from the Netherlands, and our family settled in Altadena. My mom and dad gave us a very loving Dutch home. While my parents spoke Dutch to me, I would answer in English, something my friends thought was really odd. Dad came home just about every night in time for dinner. Even our dog Scotty waited anxiously looking out the window. Dinner was always an important time with the whole family, filled with discussions over mom's soup with meatballs. Discussions ranged from what we did in school to what Dad was doing here at Caltech and mom's newest fiber art work. And of course, politics. Many discussions got very lively, but it was a wonderful way to learn how our parents viewed the world, teaching us values and ethics through storytelling. And how many of you, as young kids, did math problems with your dad? We'd gather and Pa quizzed us. And if you were on a train from LA to San Francisco, traveling at, well, you get the point. And that's without Dad's circular slide rule. My friends, so of course you know that famous one. My friends wondered how an artist and a scientist got together. Mom and Dad both embodied both creativity and curiosity, which they drew upon in their pursuits. This brought a beautiful balance to our family. Their lifelong partnership was a gift to us. And now, a few words.
So, as Anne said, my name is Marika, and I am Martin and Corey's middle daughter. And so I'd like to just share some fond memories that I have of my dad that pertain to this crowd here. As youngsters, our dad was very serious about teaching us stargazing. And I clearly remember those nights on our driveway up in Altadena on that asphalt where Dad would have us, the three of us, laying in a row, and we would be up there, and he would then very methodically go through and teach us how to find the Big Dipper and Andromeda and double stars and so much more. So you can well imagine that meteor showers were very popular to us as youngsters. We used to just absolutely love that, laying out in the driveway. And as some of you might know, a really important thing to my mom and dad was to go to Borrego Springs, California. And then some of you probably are asking, well, why would you want to go there? Why? What the heck is there in a town like Borrego Springs, California? Well, you know what it was? It's that the sky back then was really dark. It was perfect for stargazing, and Ann and I have very strong memories on how amazed we were to see the Milky Way after growing up here in Pasadena, Altadena, where you really couldn't see it very well. After dinner, we always went out for walks into the desert to view the night sky with Dad. These Borrego's adventures ended up becoming a tradition in our family that actually went on for decades. I think we did it an additional 40 years, and we included the grandchildren, great-grandchildren in this tradition. Another fun memory from childhood was that we used to love, when we were young, to go to Mount Palomar with Dad when he was observing at the 200 inch. It was, in our opinion, it was kind of an extra bonus for Dad because he got to sleep in this cottage, I don't know if it's still there, with us instead of having to sleep in the monastery, because we heard really weird stories about astronomers sleeping in the monastery, one of which seriously was that a rattlesnake was found under a bed. So anyway, but when we stayed together there as a family, one of the biggest things was who gets to go to the 200 inch tonight with Dad, you know, after dinner, who gets to go? And he always chose one of us, and it was an honor to go with him, and we were allowed to watch what was going on along with his night assistant, Gary
Tootin often.
Gary Tootin. And then sometimes we were allowed to push buttons, and we also have a clear memory, but we don't know what we're talking about, of getting dry ice or
No,
liquid
it was
nitrogen
nitrogen.
to cool instruments. We got to participate in that. So in that cage below the big thing. And also, I have to do this real quickly. I just have to mention that I have a very special memory of my father. Doesn't apply to the photo, but because my father, one of his loves was to play tennis. And he played tennis here for many years at the Athenaeum. He taught me to play tennis from the age of 8, at the age of 8. And he went on to play up until he was 88 years old. So it was a really big thing. And I'm now retired, and I've made my entire retirement about pursuing tennis through USTA. So Mom and Dad drew enormous amount of pleasure in following their daughters' lives, the three of us, our adventures in college, and as we chose careers in teaching, chemistry, and neurobiology. This was the same for their grandchildren, Alyssa and her husband Johnny, Andrew and his wife Katrina, and their super special great-granddaughters, Aletta, Avery, and Amelia. And then when Ann married Roger, Mom and Dad gained bonus grandchildren, Madeline, Matt, and Mel, and great-granddaughters, Anna and Emily. So it was just a real source of joy for my parents, especially towards the end. So with that, I would like to say thank you once again from our family. For those of you who did not get the opportunity to interact with our dad, we hope we leave you with a sense that he was above all else a gentle, kind, and loving human. His love for unlocking secrets of the universe was only surpassed by his love for his family. So sparkle hard, sparkle strong up there, Dad. We hope that you're enjoying up-close visits with the galaxies, and especially with free C-273. Thank you for getting that. We will forever look to you in the stars above. Thank you.
thank you both for this wonderful tribute. We'll now hear from a number of Martin's collaborators, students, friends, colleagues, and I would first like to call upon Richard Green to say a few words.
We all have old pictures, and we're grateful, George, for all your effort in organizing this great remembrance of Martin and his work. So for astronomers, we know that his name is indelibly associated with the first understanding of the high redshift of quasars. His recognition of that spectral pattern in 3C273, in a place where no understanding at that time would have it, provided the key to interpreting the other quasars that the folks in those days were collecting spectra of. Placing the radio source 3C9 2/3 of the way back in cosmic time forced the realization that so much of cosmic history was available for study. That was the good reason to be on the cover of Time magazine. But for the science side, the deeper paradigm-breaking impacts came in a different way. Martin applied his skills from using star counts to elucidate the structure of the Milky Way to the problem of the distribution of quasars back in cosmic time. He found in his studies of radio sources and optical-only quasars that their incidence increased strongly with distance away from us or looking backwards in cosmic time. So not only did that finding directly contradict the steady-state theory, which had real credibility in those days, but it also contradicted the strongly held view that galaxies were full-up formed very early in the age of the universe and had a sort of stately, slow evolution ever since. So these quasars are also brighter than the entire stellar population of a large galaxy, of course, requiring an energy source much more efficient than the fusion furnaces inside of stars. So that had to be, therefore, accretion energy onto a supermassive black hole, which up to that point had been objects of theorists' fever dreams. So, it was frankly an easy case at that time for me to make that nomination to the Kavli Prize Committee, because few observational discoveries have ever had such a profound effect in changing our scientific perspective on the universe as a whole. The question I ponder to this day is, what made Martin such a really great scientist? And, well, for one, he was persistent. I used to say he was like a dog with a bone when he had a problem. He would just not, he'd chew that problem over and over until he understood it. He just would not let a challenging result sit without a defensible interpretation. So the example that we all know is cracking that pattern of the 3C273 spectrum. He just wouldn't give it up until he understood what it was. I have a much less famous example of an eclipsing white dwarf, because I would feed Martin ultraviolet excess candidates in hopes of our finding bright quasars. And Martin set up on the 200-inch to see if this one was going to be a quasar. And since in the end we got 100 out of 3,000 spectra, his hopes weren't high, I'm sure. But the star blinked out in a perfectly clear sky. It turned out that it was a white dwarf star, so whatever occulted it had to be really faint. Was this the first direct detection of a planet outside the solar system? Well, Martin didn't mess around. He grabbed a week of time on the 100-inch up on Mount Wilson. He took me up there. He stayed for a night while we had a competition as to who had the best night vision to center off that 17 magnitude star. And then he left me to monitor it for a week to time the eclipses and get a really good period for that star. It turned out he also rescued me and the other observers from a massive snowstorm that was on its way. So he drove his personal car up and got us all off the mountain before it was closed for days and days. Anyway, we had a good period for that binary. We had the phase in hand. Maarten went back to the 200-inch and captured a spectrum with Bev Oaks multi-channel during eclipse. And alas, this was not the first exo-Jupiter. It was actually a very cool M dwarf. But nevertheless, Maarten wouldn't let up until this paper was written, and he leaned on me until we submitted it, saying, you know, this was a fine example. So he was very persistent. I think he was also extraordinarily good at striking the balance between finding a physical explanation that was somewhat outside the currently accepted framework, but not too far outside. So, you know, he found high redshifts because he was willing to look in a place that you wouldn't expect. He favored cosmological framework, saying, okay, a redshift tells you distance, but then there were extraordinary consequences. So he was willing to accept the interpretation of tremendous energy from black holes in preference to the really exotic alternatives that it was gravitational redshift, that redshift was something else other than distance, and his choices are the ones that have survived 50 years, and, you know, from an onslaught of supporting data and theory. So he looked ahead and picked the right path, which was very interesting. As you've heard, he was extraordinarily creative and intuitive in applying traditional techniques to brand new data and in a new way. So he used traditional star counts and said, okay, let's count these quasars and see how they're distributed. A classical statistician would not in the world have chosen his V over V max method to assess how objects were distributed in space. But he, Maarten, had his tables, you know, where each object had a calculated value with that circular slide rule. And he knew how each object contributed to the density and the distribution. So it was fully intuitive by the time he had a model that otherwise met minimization criteria. So I thought, in retrospect, he was also truly old school, and that he would choose one or two collaborators with special expertise or contribution of plain old hard work, and he would pursue his projects to completion. So he worked with Jim Gunn and Don Schneider to pioneer that time delay integration technique where you park the telescope and clock the detector and you measure everything that's passing by. That is surely the intellectual heritage of the Sloan Digital Sky Survey, which Jim Gunn went on to apply, you know, in a massive way. And they defined, Maarten wanted to look farther and farther back in cosmic time, and so they found the peak of quasar activity in that exercise, which is what we now call cosmic noon, about 70% back in cosmic time. He teamed up with Ken Kellerman, and you'll hear greetings from Ken today and me, to use the partially completed VLA, the radio telescope array, to try to figure out what the radio properties were for quasars that you didn't pick for being radio sources. And so he worked closely with Günter Hasinger in Germany to say, let's do the same for X-rays. Let's make an X-ray selected sample and see what that kind of property is for quasars. You'll hear these words often today, I think. The most important reflection that we want is that Maarten be remembered as a kind, a caring, a respectful, and really cultured mentor and colleague. As a mentor, he honestly assumed that we would learn how to observe all on our own. That was not a skill that he was going to teach. But once we had a science result, his tone of discussion seemed to be the same as with his most respected senior colleague. He would sit down and talk on a wonderful one-on-one basis. He was an absolute role model in terms of focus and rigor that he applied to his scientific work. I remember a painfully long discussion that he and I had about how to phrase one phrase in English to describe, and I finally had to bring out some etymology to say English speakers would honestly say it this way, but he didn't, you know, he really required convincing on smallest detail of every paper that he would put out. I inadvertently uncovered one of his strong music preferences. Fortunately, we shared a love of classical music, and so that made long winter nights at the telescope pass relatively quickly. But the announcer of this classical station came on and intoned, "And now, for the next hour and a quarter, we are going to hear Bruckner's Symphony No. 8. And I blurted out, "The Interminable." He gave me such a scowl that I immediately knew that this was one of his favorite composers and favorite works, and that blasphemy was not going to be tolerated. Yeah. Martin's love for family was very evident. When Joni and I had our first baby here in Pasadena, it was fantastic to see Martin stretched out on the floor of his living room, watching that little guy in the middle learn to crawl and talking Dutch baby talk, which after some wine, I'll tell you what I heard. To work together for so many nights and through so many scientific discussions was just a privilege and an honor, and that really forms a lifelong bond. And so, as an example, I had learned from a colleague that after I was off in Tucson already, Martin was going to give a colloquium in Flagstaff on a topic that we had never heard him speak about because he was returning to his love of galactic astronomy and was analyzing a proper motion catalog to get some local structure. So we went to Flagstaff and surprised Martin since he wasn't expecting any Tucson folks at that particular colloquium. And we had a great hallway conversation. And near the end I said, "You know, Martin, we've been working together so long that I understood almost everything you said, but you were speaking Dutch." So turns out that with his large frame, he occasionally had back spasms that he just needed to relieve, and that medicine had worked harder than he anticipated. So he had to go in front of the colloquium audience and say, "If I start speaking a language you don't understand, please let me know right away." So, but yeah, my preferred explanation is that it wasn't just the mechanics of that medicine, that with his warmth, with his limitless intellectual curiosity, and our many nights together at a telescope, I think he felt like he was seeing a member of his scientific family. So in our tradition, we would say, may his memory serve as a blessing.
Thank you, Richard. And for those of you who know a little bit about the local history, this picture must be a collector's item. So now we'll hear from other friends, colleagues, students, collaborators of Martin and I trust. So first, I'd like to ask Marshall Cohen to say a few words.
Thanks, George. Thanks for organizing this. And thank you to Richard Green for a wonderful discussion of Martin and his life and his work. So I have only a few words, but it will take some time. Maarten Schmidt had a long and successful career. He started young. He was working on the world's biggest telescope, Palomar, when he first understood that the strange spectrum of 3C273 was due to redshifted hydrogen. As we just heard, the details of that, it's a wonderful story. Anyway, that discovery opened up the distant universe. He became famous at an unusually young age. He was 37 years old when he was on the cover of Time magazine. His life and work will be discussed by a number of speakers here, and I don't want to repeat my view of his scientific work, and I think I'll just content myself with talking about astronomy in the early days here at Caltech. Martin came to Caltech as an associate professor in 1959. I came later in 1968. I'd been at Cornell and UC San Diego. But at that time, the senior faculty, you saw some of them on that picture that was just shown, that famous picture. Those people and a couple of others had offices on the second floor of Robinson. Martin was up there. Fritz Zwicky had been there. I inherited his office just at the head of the stairs. Zwicky had been banished from the second floor by the executive officer, Jesse Greenstein. Zwicky just retired. That was when I came. And Fritz was banished to the basement where he worked on new supernovae. Jesse and Fritz, by the way, got along best when they were separated by several floors. Robinson was rather stratified in those days, with professors on the top floor, students, including some that are here right now, students and others underground in the Bat Cave and such places. Charlie Kowal was down there. Some of you knew Charlie Kowal. He liked to talk about the second floor of Robinson as the promenade deck. People strolling back and forth, casually looking. Here's ex-students laughing at that one. In the early 70s, Martin and I developed a common foe in the person of Jeffrey Burbidge, an astrophysicist. More giggles. Some of you know what I'm talking about, but maybe not all of you. In the person of Jeffrey Burbidge, an astrophysicist from San Diego. Jeffrey was an iconoclast who argued with Martin about the distance to quasars. He claimed they had to be much closer than their redshift distance. Then when we began to catalog so-called superluminal sources, Jeffrey claimed that they proved, or at least strengthened, his case against Martin, because the standard superluminal argument involving relativistic motion, it was complicated, and Jeff's model was simple, which is that the objects are not at their redshift distance, and he had other reasons for that. Anyway, it was simple and so more likely to be correct. But of course, Jeff was ignoring all the statistics that Martin was doing. And it was very strong arguments, which, as we just heard, have held up for the last 50 years. Anyway, after a while of arguing with Jeffrey, Martin got tired. He refused to talk about it. If you try to engage him in a discussion of redshift or quasars, he usually just wouldn't talk about it, turn away. And so though his arguments, I had trouble with Jeffrey, but that's a separate story. Many years later, we left Robinson and moved into Cahill. Martin and I were retired then, and we shared a room on the second floor with a view of the tennis courts. As we just heard, Martin was an avid tennis player, but he did not waste Cahill time watching other people play tennis. No. The windows, by the way, sloped in. And the first time I leaned over to look out at the view, I banged my head on the glass. There were other collisions there that I remember too. So much for modern architecture. But Martin worked at home a lot, often was not in Cahill. He had a radio on his Cahill desk that somehow was wired into his house, and when he was working at home, the Cahill radio could start up with a news program in Dutch. So I'd be sitting there next to the window by the tennis courts, and all of a sudden, 6 or 8 feet away, here's a Dutch news program coming on. Martin's half a mile away, or a block away. I complained to him about this. He assured me it was impossible. But he retreated when we showed that his Cahill radio and his home radio came on at the same time as a certain Dutch news program. We never did understand that, but it had a workaround. which was just use the buttons that were on the radio, turn them on when you wanted to, and off when you wanted to. That was easy, rather than whatever fancy scheme he had invented to send the program from one place to another. Well, that's all I wanted to say. There's quite a few people that are going to talk, and thank you all for being here.
Yeah, thank you, Marshall. I'd like to invite Anila Sargent to come and say a few words.
So I actually want to say only a very few things because I realize that there's much more to be said by other people, and everyone has a different perspective. So mine is going to be really very short, in the sense that I thought I might dwell on a little more on the the Deadwood Society. But I thought to begin with, I would put in context the Martin that you saw and that you heard was 37 years old at the time of the discovery of quasars. My first meeting, and I didn't really meet him, I think, but my first seeing of Maarten Schmidt was sometime after the first discovery. And at that time, my late husband, Walt Sargent, and I were still at UCSD, where we were for a year and a half or something like that before we came to Caltech. I was a graduate student, and I was a graduate student of Jeff Burbage's, theoretically, because Margaret Burbage was actually in the chemistry department so that she could have a professorship. So we had to be supervised by someone in astronomy. Margaret Burbage was so excited about the discovery, not just the discovery of quasars, but the fact that Maarten Schmidt was giving a colloquium at Caltech one Wednesday afternoon, and he was going to talk about a discovery of another quasar, and she wanted to go up and hear all about it. And so she drove two other graduate students and I, who were in astrophysics at UCSD. She drove us to Pasadena, and we walked in to the old lecture hall that we used to have across Beckman Mall in the chemistry building, and there was Maarten Schmidt, and there were the slides of what he had seen. And what impressed me most was I could see that we were actually seeing, the spectral lines, and that it was certainly, if you believed his interpretation and not Jeff's, cosmological distances, or at least large distances. But this was before that was confirmed. This was really more a discovery talk. This discovery talk was greeted at lots of points by what I would have called, but remember I was from Britain at the time, I would have called catcalls from the graduate students. That, you're agreeing that was, and there were things like that. There were jokes, there were laughs. I have to say I have never seen a more animated astronomy colloquium in my life before or since. And what was most impressive was how Maarten so enjoyed this rough and tumble discussion with the young people, not just with his colleagues, and how he wanted them to ask, is it really real? And are you trying to pull the wool over my eyes? But he was, I think the whole sense of the man came through to me at that point. And obviously I got to know him better. Walt, of course, was a great friend too. And I knew him better in his role as a professor. Perhaps I didn't know him as well as I came to because of our family friendship. But I really found that his desire to communicate in a friendly way, not to compromise, but not to give in to bombast, as that we have heard about from Marshall. So really that was the first time, and I think that really epitomized him for me. I saw it later on in the department, and of course he and Wall became friends, and there were coffees often to discuss things. And gradually, as their careers went on and moved towards the end, they began to have coffee very, very regularly. Nobody was traveling as much, nobody was teaching as much. And their coffees took place on a bench on the Beckman Mall, often, if the weather was good, but you know, it's California. And so during these talks, they would sit there, they would have wonderful talks. People would pass by and possibly join in. I have to tell you that I was not aware of people being in and out. I just thought that perhaps they themselves were in and out for a moment when one of them actually published a paper or did something that was of note. But it was, quite frankly, a wonderful, wonderful friendship. And I think it was wonderful for both of them. It certainly was wonderful for Wall. And I think sometimes now, and I think you could all think that when you go by the Beckman Mall and see this bench near the door of where the colloquium used to be, I think everybody went by, they said words, there were discussions, and it was very convivial. And I don't think that I ever go by that bench without having a quiet little chortle to myself when I think about your father and Wall and all that our family knew about one another. And I think that probably is, again, a sense of the man and how he joined with others. And to conclude, I think there's not many people in Pasadena whom, if you want to, if a visitor comes from out of town and wants to see them, you actually have a solution for them, which is almost always correct. Because towards the end, as Marshall has said, Martin didn't come in so much, he didn't join in so much because of the family situation. But someone was once, a Dutchman, was pushing me. I think he wanted to write about Martin because he had written other books. A Dutchman was pushing me to have how he would get to see Martin. He couldn't go to his house, and I said, definitely not. And he wasn't in his office, and what could you do? And I said, well, you know, if I were you, I'd just go right over to Celestino's for dinner tonight. And I'm sure you will see Corrie and Martin on the back, sitting at the back wall, enjoying their dinner. I used to have great joy. I think Sunyaev was the last person I actually said to who said, "Where is Martin?" And I said, actually, right behind you. Would you like to say hello? And that was not the only time. So Celestino's is also, sometimes Nick Scoville and I, my colleague, go to Celestino's for dinner, and I don't think we ever go there. I'm just going to tell you, except saying, well, do you think Martin and Corrie will come tonight? And I'm sure that sometimes they're there. They're certainly, for me, there in spirit. So I think this is a wonderful celebration that's been put together for him. I think it honors the man and your mother, who was so much part of it. And I'm just so glad that we're able to honor him in this way. And I'd like to just say, you have so much behind you, a wonderful life, a life full and terrific. And I think that was Martin. So that's my small piece. It's not anything from the notes or anything. So thank you.
Thank you, Anila. Now we have a few messages from Martin's former students or postdocs who couldn't be here. And the first one is from Don Schneider, who obviously felt really guilty about it because he wrote a very long one, which I will read. I don't know if that's shorter than some. So here we go. Each of us in our lives have been influenced by a wide range of family, friends, and acquaintances. A few, e.g. parents, teachers, colleagues, have had an enormous impact on who we have become. Maarten Schmidt was one of those special people in my life, and I wish to pay tribute to one of the most impressive individuals that I have encountered in my journey. You all know him as a groundbreaking scientist who reshaped our view of the cosmos, and he was indeed all that. But my memories center around his personal qualities, his kindness, wisdom, and ability to infuse younger generation with his enthusiasm of the quest for knowledge. My first interaction with Martin was a graduate student in Robinson Hall. My desk was located in a multi-student office known as the Bat Cave. I was alone in the office one afternoon in 1981 when I answered the phone with the standard phrase, boldly spoken, "This is the Batcave." I was greeted with silence on the line for several seconds. Then a familiar voice said, "Yes, may I please speak with Donald Schneider? This is Maarten Schmidt." And I was more than a little bit embarrassed. I contemplated altering my voice and replying, "Yes, let me go fetch him." But in the end, I decided to continue this conversation. At that time, Maarten was on sabbatical at the Institute for Advanced Study, and he asked me to become his postdoc. The following decade was definitely the most productive and enjoyable of my career. Maarten, in close collaboration with Jean Gunn, who was my thesis advisor, developed an innovative approach to harness the power of the new detector, the charge-coupled device, to survey large, for the time, areas of sky. This technique, time delay and integrate, or scan mode, required considerable hardware and software modification, but by 1983, Maarten began a series of surveys designed to detect high redshift quasars, those with redshift greater than 3.5. I still recall the first moments of the scanning program. We had completed all of the tests possible without any sky observations and eagerly anticipated the arrival of evening twilight. I was in the prime focus cage of the Hale telescope to manipulate the equipment, while Jim and Maarten were in the data room. I asked over the intercom what direction to set the base, and I received the reply, either 90 or 270, doesn't matter. The exposure was started, and within seconds we were confronted with evidence that we had spectacularly failed in our year-long effort. Instead of beautiful tapestry of stars serenely drifting across the monitor, the screen was filled with series of bright and dark lines that began and terminated in a bizarre pattern. There were several minutes of despair as we contemplated this disaster. Then a voice from the control room stated, "Motion is a vector. Set the base to 270. I had chosen to orient the instrumentation in exactly the opposite orientation required for proper operation. I cannot express the delight I experienced working with Maarten. There were countless meetings with him in his office in the northwest corner of Robinson, where we planned the next observing run and discussed the challenges of processing the data. Best of all were the trips to Palomar. Maarten was an exceptional conversationalist with a broad historical background, offering advice and always leveling discussion with his wry sense of humor. The actual observing was exhausting but exhilarating, although the conversations did tend to lose significance and occasionally coherence by the time 4 a.m. arrived. In 1985, I moved to New Jersey, but I continued to work with Maarten on the quasar surveys and later on his program to optically identify sources discovered by the newly launched Rosette X-ray satellite. My favorite memories of that time were the frequent dinners I would have on the eve of our departure for the mountain. Maarten and Corey treated me as a part of their family, and I particularly remember her delicious homemade soup. I consider myself incredibly fortunate to have been able to closely interact with Maarten for so many years, to have been the recipient of so much of his guidance, and been able to experience the thrill of witnessing firsthand his approach to scientific investigations. To me, he was the quintessential a gentleman and a scholar. And now, a video message from another major collaborator of Maarten, Günther Hasinger, who is very busy setting up the biggest astronomy institute ever in Germany.
Dear colleagues, it's a great honor and pleasure for me to say a few words celebrating Maarten Schmidt's life. Maarten Schmidt became something like a father figure for me. And here you see him in his house on California Boulevard. I had not only one surrogate fathers, but 4. And here you see the picture. On one hand, Joachim Trümper, Maarten Schmidt, Riccardo Giacconi, Yasuo Tanaka. And in the early days of the Rosat mission in preparation, and also during the Rosat mission, we were working on the Rosat deep surveys. We had many, many meetings in Garching, and then also later when I moved to Potsdam, where Maarten always came to visit us. But he also introduced me to optical spectroscopy on large telescopes. And this all started in '92 at the Palomar 200-inch telescope, where he actually first climbed with me through the dome up onto the roof of the dome of the 200-inch. And here you see him standing on the rooftop, wonderful panorama, and also myself as a young kid learning from Martin. And Martin also, he's probably the person who spent most time in the world in the prime focus cage of the 200-inch, and so here he happily climbed into the prime focus cage of the 200-inch telescope. And this was the starting time for the very large multi-object spectrographs. It started with a 4-shooter, and then later Martin introduced me into spectroscopy at the Keck telescope, with ELRIS first and later DEIMOS, and this kicked off a whole career which finally also let me end up as a director in Hawaii. And you know, Martin loved to visit on the summit. He basically insisted on observing from the summit. And this happened even while most of the other astronomers were already observing from Waimea, which is much more convenient. But Martin insisted to be up on the summit. He wanted to see the weather, he wanted to see the clouds, to sniff the air. But most importantly, he wanted to be where the telescope operator is. And there was one year when the telescope operator was not able to go up to the summit for health reasons, and we were already up on the summit, and when Martin saw that, he said, no, we go down, we observe from Waimea. And from then on, we basically observed every year from Waimea because it's much more convenient, and we also are able to go for dinner during the observing lunch, during the observing run, and so on. So this continued throughout the 90s. In the meantime, we have moved to Potsdam, and so Martin also regularly visited us in Potsdam, actually similar to Yasuo Tanaka. And here you see Martin and Yasuo and his wife and my wife at a dinner in Potsdam. This is actually asparagus time. I love asparagus, but Martin hates asparagus, and mainly for the smell of it after you have eaten it. Anyhow, one of the memorable events was also when I then moved back to Garching to become Joachim Trümper's successor. And this is a picture of Joachim Trümper's retirement party, where you see Joachim, you see Rudolf Kippenhahn, you see Ed van den Heuvel, and then in the back row Martin, my wife, and myself. So this was when I started to become the director in Garching. He still accompanied me then throughout my career. Whenever I was at Caltech or visiting in the region, I actually visited him first in California Boulevard, and then later more and more in the pizzeria where he and his wife Corey had their dinner almost every evening. And it was so sad to lose Martin. I really miss him. And Martin, I thank you for all of what you have done for humanity, but also particular for my own career in my life. Thank you very much.
And we have another video message from Donna Weistrup, another one of Martin's students.
Sorry I couldn't be in Pasadena with all of you to celebrate the life of Maarten Schmidt. I first encountered Martin at an Astronomical Society meeting in Montreal, Canada in December 1964, where he was speaking about quasars, of course. As a nervous college senior, I approached him in the lobby to ask what I'm sure was a very naive question about redshifts. Being Martin, he gave a very polite answer. The following fall, I entered graduate school at Caltech, and after a few years of coursework, Martin became my dissertation advisor. He was always kind, considerate, and supportive of graduate students, especially me, although I don't think he appreciated my use of computer programming notation in the equations in my dissertation. He was also kind enough to write many letters for me when I was job hunting, and I'm sure thanks to him I've had many interesting positions in my career. Of course, his scientific contributions changed our understanding of the evolution of galaxies, as witnessed by his many awards. It was my great privilege and honor to know Maarten and to be his student.
And now, let me read you another message we received from Martin Rees, who proverbially needs no introduction, and unfortunately could not join us because he's restricting his travel these days. I encountered Maarten during extended visits I made to Caltech when I was a postdoc in 1968 and 1970. His classic pioneering work on quasars, by then already done. He was already a famous name. I didn't expect much attention from such a celebrated figure, so it was a real plus to have a friendly interaction and mentoring from him at the Athenaeum lunches and in Robinson Lab, and even to write a joint paper on quasar redshift distribution. Many of my Cambridge colleagues collaborated with Maarten. They deeply appreciated the chance to work with him. He was a superb scientist and a role model. We were delighted when we shared the first Kavli Prize with Donald Lindenbell. We're all saddened by his passing and remember him warmly and with gratitude. Martin Rees I encountered during the extended visits I made to Caltech when postdoc in 1968 and 1970. Anyway, that's all Lord Rees had to say. I'm going to ask Mike Werner to say a few words.
Well, thanks very much, George. It's a pleasure to be here. I knew Maarten in various ways, but one that really hasn't been mentioned is that he was the division chair at PMA when I was denied tenure at Caltech in 1977, I think it was. And apropos of what his daughters had said, he treated me with kindness, grace, and dignity during that difficult period. And I remember him very warmly because of that. Thank you.
Now, it's probably not well known, but Maarten was also deeply involved in public outreach, and we're lucky to have Director of Griffith Observatory, Ed Krupp, who will say a few words about that.
Obviously, George, thank you very much for this invitation to join this remembrance of Maarten today. And thank you all for giving me the opportunity to outline briefly contributions you may not know he made to public astronomy and astronomy education. He was generous to Griffith Observatory with his time, his insight, and his perspective. Griffith Observatory owes a debt to Maarten for what it is today. I actually first met Maarten, however, long before either his or my serious involvement with Griffith Observatory. He played center field in a softball game at the Thatcher School in Ojai, California, and then delivered a memorable lecture on quasi-stellar radio sources to the students and faculty of the 11th annual summer science program, that intense immersion into college-level science and astronomy for academically competitive high school juniors. Distance from Caltech to Ojai is not cosmological, but is also not trivial. And Maarten then, and numerous times after, personally supported the summer science program there, making that trek, and the students always understood that an astronomical legend had come to see them. Later, Maarten agreed to join the Griffith Trust Advisory Committee and help direct residual funds to Griffith Observatory needs and initiatives. This was money left over from the construction of Griffith Observatory, but was not necessarily in the hands of Griffith Observatory, so it was a delicate resource. Eventually, one of those initiatives was the Griffith Observatory Master Plan, which defined and guided the principles and objectives for what eventually came Griffith Observatory's $93 million renovation and expansion. That expansion and renovation would not have happened without the master plan, and there would not have been a master plan without Maarten. Maarten was also a founding member of the Friends of the Observatory, which partnered with the City of Los Angeles and Griffith Observatory for the observatory's renewal. And the run-up to the renovation and the expansion of Griffith Observatory was demanding and complex, and Maarten routinely provided this thoughtful counsel that is still remembered today, about 30 years later, as some of the most spare, cogent, and inspirational guidance that the organization had ever enjoyed. In recalling Maarten, another board member said, "He was astonishingly good at meetings. listening, speaking when appropriate, and reaching the best solution. Then he was remarkably persuasive. And at a moment when everyone else was fatigued and overwhelmed, he made it seem the project was doable and worthwhile in every way. And of course, the gravitas that he added to the project's profile was noticed by the city, the Department of Recreation and Parks, and all of the future stakeholders, none of whom had a direct connection with astronomy. Martin had been quoted in print as saying, "To me, the universe became more and more incomprehensible." And I am sure that in part is why he was so able to be so effective on behalf of an institution owned and operated by the city of Los Angeles. He knew what he was dealing with. As we were consolidating the design and the character of Griffith Observatory's restoration, Martin took note of the transformations taking place at other institutions dedicated to public astronomy. And he documented his concerns in one of his letters to me. And speaking of his first experience with a planetarium 60 years earlier in The Hague, he wrote, "At the first performance that I attended, I was deeply impressed by the gradual dimming of the light in the dome while music was playing, and slowly the stars started to appear, one after another. The transition providing a link between daytime, human environment, and the nighttime experience of the starry sky. I felt and still feel that this connection is a unique contribution of the planetarium to get people to understand our near cosmic environment." Well, his thoughts were on target then, and they remain relevant today. Given Martin's sentiments about life, the universe, and everything, it should be no surprise that he once confirmed that his very favorite thing in the world was lying in the backyard on a blanket with Corey, sharing a bottle of wine, looking at the sky, and talking about nearly everything that interested them both. This all sounds a bit like the sentiments of the celebrated Persian poet and wine enthusiast Omar Khayyam. And by profession, Omar Khayyam was an astronomer, and Martin certainly belongs to that lineage. Thank you very much.
Thank you. And now I'd like to invite Bob Kirshner to say a few words with his customary seriousness and gravitas.
It was 1966, and I was a senior in high school, when my Aunt Pat came across the street with Time magazine. "Bobby," she said, "you've got to read this." Our family was a Newsweek family, and we didn't know what Time magazine really was about. But I got to say, when I read that article, I thought, I want to be that person. I want to do that. And then, I'm not blaming him, but I did become an astronomy major at Harvard, and I came to Caltech in 1970. And some of you may remember the ritual of the placement exams, where incoming graduate students had the opportunity not to take the mathematical physics course if they did well enough, not to take the quantum mechanics course if they did well enough. And I had 2 pi I times the sum of the residues, and I did that stuff because I didn't want to take those courses. But I'd taken a lot of astronomy courses at Harvard, so I thought, I don't have to study for this. So the instructor gave personal oral exams to determine whether the incoming students needed this brushing up for a course that graduate students and Caltech undergraduates could take. Astronomy 111, I don't know, some number like that. So I wasn't worried. I went to see the instructor and I realized this is Maarten Schmidt. Wow, that was great. Up to a point. And here it is 53 years later, and I still remember the questions that I was unable to answer. He said, "Draw a spectrograph." I said, "Draw a spectrograph, of course I will. Here's the dispersing element, here's a camera, a recording device, and so on." And he waited for me to say the right thing, which I did not do. And then he gently said, "Shouldn't there be a slit in there somewhere?" I thought, well, Let's go on to the next question. Then he said, well, how do we know, he said, how do we know that the galaxy is rotating? And I said, well, anybody, it's flat, like all the other galaxies. That's, of course, it must be. And he said, well, he waited. And he said, wouldn't you want to know something about the Oort A and the Oort B, which is astronomer talk for how the stars are moving in the neighborhood of the sun as you look around in different directions, a subject that had been studied with great benefit by Jan Oort and his associates, including a very good PhD student, as I understand it, Maarten Schmidt. Well, the short form of the story is, I took the course. 53 years later, I can't remember anything that was the substance of what he was teaching in that course. Only the gentle but firm placement exam administered by Maarten Schmidt. Now, I've been reasonably successful in astronomy, and I think that this shows that it's not the content of the course that really matters. It's the spirit of discovery, which Maarten communicated greatly and every day, and the warmth of the faculty that was toward the graduate students, which was much more important than any specific knowledge. So even though I know he said that it was a terrible time when he was on the cover and so on, Maarten Schmidt is still a hero to me.
Thank you, Bob. I mentioned Schmidt's law, one of his first scientific discoveries, and Rob will kindly tell us more about it.
Thank you, and thank you for inviting me. So, as you've heard, we all associate Maarten's science with quasars, of course. But as George mentioned, before quasars, in those roughly 5 years from his PhD to that discovery, his passion was understanding the structure and evolution of the Milky Way. And it may surprise you to know that his most highly cited paper of his career, by a country mile, is entitled The Rate of Star Formation. Actually, 2 papers back to back. And it's famous in part because it's where Schmidt's law was introduced. I'll tell you what that is in a second. The motivation for the study, actually, interestingly, was not really to gain a deeper understanding of the physics of star formation. It was a means to another end. He wanted to construct one of the first models for the evolution of stars and gas and metals in galaxies. So to do that, if you want to understand how stars form, you need an equation. And so he made an assumption, speculated, that the rate of star formation probably depends on the gas supply, probably on the density of the gas, to some power law that you would determine through observations. Now that's a very powerful formulation because there's a second relation, right? Whenever you make stars out of gas, you reduce the amount of gas by about the same amount as you gain in stars. In the language of calculus, it means that the rate of star formation is also the time derivative of the density of gas. So there you have it, 2 equations, 2 unknowns. That's all you need. You can do it on the back and you can construct, for whatever power law you like, a model for the evolution of the gas and the stars, in this case, in the Milky Way. One of the first times anybody did that. In the second paper, published 4 years later, he added metal enrichment and devised one of the first chemical evolution models in galaxies. And then he applied it to observations at the time to try to measure the evolution of the Milky Way and its star formation rate. The results of those models were soon forgotten for the simple reason that he was too many decades ahead of his time. We just didn't have the data. For example, the only gas known at the time was atomic gas. We all know now today that gas in molecular form is really critical for this. Had to wait 20 years basically for those observations to come along. Nevertheless, the impact of the paper was absolutely enormous. On the one hand, it inspired people like Wal Sargent, Leonard Searle, Beatrice Tinsley to carry the torch and develop essentially the whole field of galaxy evolution modeling.
that is now, a huge field, one of the raison d'etres of the James Webb Space Telescope. And it inspired a generation of young observers, myself included, to go out and see if we could test whether that Schmidt's law really applies in our universe. In fact, I told Martin that the first time I met him was 1978, when I arrived as a Carnegie Fellow, Santa Barbara Street. He was a Carnegie Fellow, and he did this work, by the way. And he had arrived as the director. He wished me luck and said he'd prefer to work on quasars. Well, that long story short, 20 years later, I finally finished the project. Lots had to happen in between. And we found is that our universe follows that. That law is beautiful. The galaxy is over a huge range of physical conditions. It fits wonderfully. I presented those results here on campus shortly thereafter in an astronomy colloquium. I didn't know at the time, but Martin was in the audience. And as soon as I was finished, he came bounding down to shake my hand, congratulate me. And I still remember the exact words he used. Is, Bob, he said, he always called me Bob for whatever reason. I believe it. And for him, that praise does not come higher than that. Almost done. So my last memory, I think one most precious to me, came the last time we interacted. That was 2009 in Tuscany. The Arcetri Observatory decided to organize a week-long conference in honor of the 50th anniversary of the Schmidt Law. That's how big this paper was, right? 100 people showed up. It was a wonderful week. First morning, of course, was full of speeches, honor. Martin was the guest of honor, of course. I'm pretty sure Corey came as well. And anyway, the memory I want to describe is, so there were discussions in the morning. I've left out an important piece of the story, though. Over the 10 years, from my paper to the validation of the law to this conference, a lot of people stopped calling the Schmidt Law the Schmidt Law. They started calling it the Schmidt-Kennicott Law, or worse yet, the Kennicott-Schmidt Law. And it never sat really entirely well with me. Anyway, so we're at the coffee break on the first morning. And in fact, at the meeting, early in the morning, people are doing this, right? They still do it to this day. So I'm in line waiting for my espresso, and I hear a voice behind me, Bob. It is. So I turn around, and he's waving and said, come on over here, let's have a talk. And took me to the side. He wanted a little privacy. And he said, I just want to, he said, I've noticed that they seem to be associating this law with both of our names now. And I said, yeah, sorry about that, not my idea, right? And he said, well, I want you to know, not only am I okay with that, I'm delighted that they've done this. In fact, he went so far almost to say that he was honored to have his name associated with mine, with his law, right? So, and I think, obviously, one of those, precious, priceless moments in a career. And I think, to repeat, I think adjectives you've all used already, just I think illustrates not only how brilliant, he was a brilliant scientist, but also incredibly kind, generous, and supportive. And I'll leave it there. Thank you.
And we have one more message, which is from noted radio astronomer Ken Kellerman, who planned to be here but couldn't make it. So I'll read that one. I suspect that it is rare that a single individual has such a long-lasting input to a field that he or she created as did Martin. Martin not only discovered a totally new phenomenon, quasars, but over a period of years worked to define their luminosity function and its evolution. Unlike typical current computer-based analysis of huge astronomical databases, guilty, I was always impressed how Martin would just use a simple slide rule and his innovative V over V max test to understand the deep implications of his observation of only a few dozen quasars. On a personal level, I first met Martin as a first-year graduate student when I took his radio astronomy course in 1960. Much later, when we collaborated on several papers concerning the radio emission from radio-quiet quasars, he taught this physicist a lot of astronomy. More recently, when I was doing research on the discovery of quasars, Maarten generously shared with me his 200-inch telescope logs along with his notes and correspondence with Bolton, Hazard, Greenstein, and others, and we fully collaborated in jointly trying to understand what really happened during those exciting days in the late 1962 and early 1963. And I will be forever grateful when, as the president of the AAS, Maarten stepped in to help get our BLBA proposal funded by Congress. Maarten and Corey were always kind and hospitable to me on my frequent return trips to Caltech, and it was my privilege to have known Maarten for more than half a century. So, as you heard, Maarten started his scientific career by trying to understand more about stellar and galactic astronomy. I thought it would be fitting to end this with look forward in what's now one of the most vibrant and hottest areas. And so Juna Kohlmeier, a former Caltech undergrad, director of Center for Theoretical Astrophysics in Canada, and PI of Sloan 6 survey, has few things to say about that.
Well, thank you so much to the organizers for inviting me here to speak today. I feel quite out of place speaking at this wonderful occasion. For one thing, as a former undergrad, no matter how many degrees and titles I accumulate, I will never ever feel at home at the Athenaeum. This had a distinctly children should be seen and not heard vibe when I was here, and I remember that. And as Dan Stern in the back reminded me, the last time we were here celebrating Maarten's legacy and quasars, very memorable moment in Dan's life. Maarten came up to the two of us and gave Dan a big hug, but he did not know me. And so I did not receive a hug. In fact, Maarten Schmidt was a celebrity. I was an undergrad in, I think, what is the Bat Cave. And occasionally you would see in Robinson this tall figure walk across, and we would just say, "Is that Maarten Schmidt? Is that Maarten?" We would just be, he was already so out of reach for some of us. But for another thing, Maarten Schmidt's impact on the field is so enormous that anything that I say is destined to be just an extremely faint, high-order reflection of an extremely luminous giant. And in fact, this celebrity that we would just occasionally glimpse permeated so much of the training and so much of the field of astronomy that in many ways we have this echo embedded within us and within what we do without even always recognizing it was from him. I'm now the director of the Sloan Digital Sky Survey, as George said, and I began my work in the DPAS Army with George and Dan in the Bat Cave, classifying quasars and trying to understand how quasars grow. But I realized, and this is just in this room, not to be shared more broadly, we can really call it the Schmidt Digital Sky Survey among friends. Of course, Maarten Schmidt's famous for the quasars, and in SDSS 5 we have our black hole mapper, and I think we're still doing justice to the work that he started with Richard Green and Don Schneider and Jim Gunn. And in fact, Don Schneider is still working on the SDSS 5 quasars, trying to understand how black holes grow, trying to understand the luminosity function of quasars, trying to understand this incredibly weird thing of Schwarzschild throats. What are they, and how are they working? And of course, he's, as you just heard from Bob Kennicott, he's famous for the Schmidt law, and in our local volume mapper, we're still struggling with how the damn stars form. So what is the feedback of stars on the gas, and how do they form out of this gas? And so that second mapper that we're doing is intended to answer those same questions. And I was asked by George to speak about the Milky Way, and of course, Maarten did his PhD with Jan Oort, working on the dynamics of the Milky Way, and his thesis entitled "The Mass of the Milky Way." In fact, in 1964, he was asked to give a review of galactic problems. And so, seeking some inspiration from Martin's own work, I wondered, what were the galactic problems in 1964, and how much progress have we made on all the galactic problems? So, some major problems. Number one, the makeup of the local density. That's still a problem. Number two, density gradients towards the center. Check. Spiral structure, also still an issue. Radio corona, working on that. Correlation with stellar mass. This is the velocity distributions of the stars and their correlation with stellar mass. I think we have more of a handle on that with these big surveys that we're doing of millions and millions of stars in the Milky Way. The vertex deviation, again, and spiral structure. In fact, things like the Sonderos Sky Survey and the Gaia satellite have revealed issues in the spiral structure, more issues. So again, not solved. Gas dynamics and magnetic fields, always magnetic fields, not solved. And large-scale deviations from circular motion. So why were there these big deviations of the stars from just purely circular orbits? Still working on that. And evolution, this was the best. He lists all the subjects and then all the issues. And then under galactic evolution, he just writes one, all problems. And indeed, with my theorist hat on, I said, well, we have solutions to all of those. But in fact, with your empiricist hat on, you say, no, that's correct, all the problems in galactic evolution. So when I dug into these archives to understand, okay, well, where did we come since 1964? Because we had actually been working super hard and making a ton of progress. I became quite excited and a little distressed. I believe we're actually solving some of these problems now. And these problems many of them, particularly in galactic astronomy, sat fallow. And that's because the fine-grained information we have about the Milky Way makes it a bit of a pain in the neck to understand in detail how it forms. When you think you've understood something, something weird comes up and you have to then explain that. Whereas when they're just smudges in the vast reaches of the cosmos, you can hide a lot of misunderstanding under those smudges. And that cosmic variance and that cosmic numbers, or that cosmic picture, actually does a lot of the heavy lifting for you. In the galaxy, you don't get to hide anything under the rug. It's all there, and you see all of the mess. And that's the beauty, is actually all of that incredible phenomenological structure and what it's telling us about the physics and evolution of stars and the galaxy. So we don't have the cosmology doing the heavy lifting for us in the Milky Way. We just have to do the heavy lift ourselves, and we are doing it. And in fact, I was unaware that Martin was the pioneer of the Sloan drift scanning technique. And so I do think it's appropriate to, at least in these circles, have that moniker for the survey. And I guess outside of the astronomy, I just want to highlight something that I think is really important, because I don't have a personal connection with Martin, but his work obviously is extremely important and permeates a lot of what I do. But something I think is quite remarkable when you read about Martin's history and his childhood, he just describes going to school in bombed out buildings and famines, and being a starving student and a starving assistant professor, a fact that Caltech and Carnegie shamelessly conspired to exploit by re-offering him a Caltech position, which he accepted after a year back home. He describes the drudgery and lack of support for lower levels of administrators from upper levels of administrators, inflation woes in Chile, and of course, Caltech-Carnegie relations. It actually brings about a great calm. Because if that bright light is able to shine through those circumstances, when we look around, we see all of the difficult circumstances that we are faced with. And it's not hard to find those circumstances, opening any paper or other thing. It's quite calming, and it shows that, there's a lot of change, there's a lot of bumps, a lot of wiggles, a lot of highs, a lot of lows, But there is homogeneity and isotropy on large scales, and it's all going to work out just fine. So thank you, Martin. Thank you to the organizers. Thank you to Mark's family. What a gift to humanity, and what a gift as a student who just through osmosis, being in the air, was able to benefit. Thank you.
Well, that completes our program. I want to thank all of the speakers and thank you all for coming. And now, please enjoy the little reception.
The Dutch what?
The Dutch baby talk. But we had our baby, so I'm Richard Green's wife.
Yeah?
Yeah, so our baby, and he just went into Dutch baby talk when he met our baby. So.
Tell you one other little anecdote, which I thought was a little too silly, if that's...
You silly?
Well, anyway, here it is. So I think it was the first year I was here, and there was a Christmas party, which was pretty good. And I went to a lot of trouble, I guess I went to the place, to get the license plate bracket from Maarten Schmidt Oldsmobile, which is in Monrovia or someplace. But it wasn't spelled,
Quite right.
quite right.
No two A's,
And
yeah.
two things about it. One is he said, my daughter fixed this. I don't know which of you would have been the one to fix it.
Al's probably.
But anyway, and he got two A's in there. And he put it on the car. He put it on that is a sign of a good sport.
Yeah.
So he did think it was funny.
Yeah.
But he wanted to get it correct,
Oh, yeah, right. Of course.
So anyway,